It's my pleasure to invite Dr. Helen Parkinson to give the fourth keynote of SWAT for Life Science 2019. Helen's been a long-time friend of the conference and has supported us through various stages, including, I believe, the 2005-15 edition. Very much, so we definitely appreciate that. And this year it's her turn to give the keynote. So the title here is Fair Vocabulary Odyssey. She's asked me to keep her biography very, very brief, because otherwise we'll be here for quite a while. And it suffices to say that Helen is the head of molecular archives and samples and ontologies team leader at the European Bioinformatics Institute, and she's been involved in bioinformatics for 20 plus years. So I'll hand over the microphone. Thank you all.
So thank you for the invitation. Thank you for inviting me again when I said no the first two times. I have guilt about not coming, and I love this meeting because I really like the diversity of things that you do. So I'm going to talk about a fair vocabulary odyssey, and I will attempt to entertain or provoke slightly with the intention of provoking some discussion. So let's see how we go. So who knows the story of the Odyssey? Good. Okay, so if there are going to be questions about the Odyssey, the people with their hands up will be answering those questions. So to orientate you a bit, the Odyssey has a non-linear plot. It's about Odysseus' voyages and his journey home, back to Penelope, his wife. We are only going to be looking at the monsters and the challenges in this presentation, because those are the fun bits, and I thought it would be an interesting thing to hang it on. I haven't tried to hang the presentation on the whole Odyssey. I've just picked out some pieces. So we've got the Lotus Eaters, who are the pleasure seekers, Circe, the goddess who turns the crew to swine, the Sirens who tempt Odysseus' sailors with their song, the six-headed cave-dwelling monster that is Scylla, and the whirlpool that is Hopeless. I'm possibly pronouncing that incorrectly, which I apologize. So that's your Odyssey primer. There's a journey, lots of things happen. Eventually, as Odysseus gets home, and I'm going to align some of our activities in the fair space on this. So we've already seen the fair indicators at least twice today. These ones were from the RDA. And on the 9th of August, when I agreed to do this, I started to think, oh, it's interesting, I should go and have a look at some of this stuff and have a bit of a think about it. So I did, and I was talking to Nick Duty from Carol Noble's group in Manchester, thinking about what's interesting. And so this discussion was happening about optional versus recommended. And I started to get interested because it was August and I had time to think. And so on one of the principles, my point was, if there are no fair compliant vocabularies, how can you be fair? Right? We don't know what constitutes a fair compliant vocabulary. Are there a different set of fair principles that correspond to the features of a fair vocabulary? And Max Decker's commented, no Max, maybe he's here, that said, yep, you're right. So we've got a problem. If there are no fair vocabularies, the indicator cannot be satisfied. So we've sort of got a conundrum here, and Hervé LH, whoever that is, said, yeah, it's recursive, right? We've got a problem. And because we deal in vocabularies, but also we hope in fair data, I started to think about what should we do about this. So, why do we need to be fair? What tools do we need to be fair? And how do we know we are fair? But thinking about that in a vocabulary context. And I'm most interested in the interoperability pieces of fair, because that's the world I work in. We're trying to make data interoperable, and I'll talk a bit about why we do that in a moment. We work at scale. So we're 110 people working with some of the world's largest data resources and probably the largest bioinformatics institute in Europe. And we really have to make things work at scale. And so we think a lot about how we pragmatically approach what the users do. And so Scylla, if you remember, was the six-headed cave-dwelling monster, and Shadwis is the whirlpool. And here are some images from those. All the images are from Wikimedia Commons, so thanks to Wikimedia Commons for providing the images. And this is where I live, right? So I live in a world of increasing data growth. The things on the top here, the small graphs, are the data growth profiles for the nucleotide archive, so constant data flow. We're up to 273 petabytes of raw storage, so significant storage. And we're at 64 million web requests per day in 2018. So this is the sort of scale that we work at from our secure data archive. We streamed out 5 petabytes of data in the last year. So that's just data flow from one data archive. So it's really big. And so all of this stuff comes with metadata, and much of it is processed from raw data archive pieces into knowledge bases. And the knowledge bases are where it gets interesting, and we try and apply vocabularies in both spaces, but that's not always possible for reasons I'll go into in a moment. So EBI is kind of arranged like this. We are not predicated on any one kind of data. There are data types coming from sequence, some clinical biomarkers, protein structures, all the way up to population data for population cohorts, and lots of microbial things and plants. So the problems we're trying to solve are very, very general problems. And trying to build useful scenarios for these general problems is challenging. And this is why it's challenging. So in practice, the data that comes to us, particularly the metadata, is dumped in or from some external database, edited by several people in Excel, using some local vocabulary, so some words, they knew what they meant, the spelling and syntactic variation is completely uncontrolled, and there are no definitions of the column headings and no versioning. That's kind of how we get the metadata. And that's the good metadata. Some of the very large centers stream metadata to us in very, very thin layers, so it tends to be accurate but not rich. And so we spend a lot of time trying to add value to this. So we're between Sinner and Jabberix. So streaming stuff out and making sure people can use it, choosing how we then modify that to make it fair and to make sure that we can make the community make things fair so we don't have to do all of that. Because we're doing the heavy lifting of moving all that data around. So what's our ambition? And so these are the Lotus Eaters. The Lotus Eaters sat around having a good time and subverting Odysseus' crew. And they were about pleasure. So pleasure for me is when I get to go and build ontologies just because I want to build ontologies. I love to build ontologies. It's what we do to have a good time. But what we're actually trying to do is make the data fair and apply these things at scale. And sometimes that brings its own set of challenges. So we want to build fair, capable resources. So we want the resources we build for the community to be fair, capable. But we're not quite sure yet what fair, capable is. And it's different in different contexts. So we want to apply, integrate, analyze, and present fair archival data in our knowledge bases, and to determine the fair context for our resources and data. And all of these resources are different. Some are very specialized, some are very general. The context is important. We want to have context-relevant fair indicators, and I want to define what constitutes a fair vocabulary. And that's the choice I made for this tool. We'll see what we get to at the end. So if we think about the biomedical ontology landscape, I've drawn it here with the kind of the domain areas as a kind of Tetris type model of all of the pieces that you have, which might be the biological access, environment, sequence, gene product, cells, up to disease, and also properties of cohorts. Because we're getting into that now. And then we've also got chemistry, methods, experimental design, imaging. We had a nice talk on imaging this morning, and data use. And because our data looks like all of these things, we're describing both the molecules and the chemicals and the experiments and the knowledge, we're effectively stitching these things together in a fabric that look like our data. And so we're kind of aggregators of data and integrators of ontologies. And to do this, we pull the ontologies apart and we put them back together. And people like Henriette is here, and other people in the team do this in different contexts. We do it for the Fly Connecto, we do it for GWAS, and so on. So I'll show you some of our applications. The GWAS catalog, 100,000 unique users a year. All of the high p-value variation trait associations from large GWAS studies. And we curate them in the literature, we apply the summary statistics, so millions of SNPs, and then we try and make them visible in this diagram, which shows all of the traits color-coded by another level category onto the carrier type. And this one's cardiovascular disease, red is cardiovascular disease. And people want to come and visualize this, but they also want to interrogate the data. So that's one example. The second one is data use ontology. So I said we streamed 5 petabytes a year of secure data. The challenge with the secure data from the European Genome and Phenome Archive is that actually understanding what you can use it for and getting access to it is a very manual process. We don't expose that very nicely for users and say, you can't use this if you're a commercial company, or this is for general research use, it doesn't have to be cancer research. So my colleague Melanie Courteau, who did this work in collaboration with colleagues from GFGH, has built an ontology for this, and we're starting to mark up the data. It's not just being used by us, it's being used by all of us in the US, it's being used by GWAS, which is a grade system, and it's being used by Stage, and I confess I don't know what Stage is. But these are big projects, all of us is a million Americans who are going into the system. Hopefully we'll have a nice thin layer of markup that tells you what you can use the data for. And then the final piece I'll talk about is, this is disease associations for bone morphogenetic protein receptor 2. So I was involved in the positional cloning of bone morphogenetic protein receptor 2 a long, long time ago when positional cloning was a career path. and there's a good reason I'm a bioinformatician. So this is the data from open targets, all of the data from the animal models, from the known genetics. There are some somatic mutations for this, and also the literature has been mined out and is marked up with an ontology that we built. It's the same ontology that we use for the genus catalog, but the presentation is completely different. So this is an area where we're applying the same thing at some reasonable scale. So this is our problem. We're trying to solve these scenarios where we have to mark up data and make it useful. So I called this slide The Temptations of the Sirens. So the sirens were the mythical creatures who lured Odysseus onto the rocks, and so he put wax in the ears of his crew and he lashed himself to the mast so that he couldn't be tempted to go join the sirens. And I think that the siren song for me in this space is the formalisms and the tools, right? So the formalisms, this is a slide from my Bergman. It's an old slide. I think it's from 2008. Credited here, talking about the cost of and the choices of formalisms, right? So time is money and complexity costs more. If you have less strong semantics, so if you just have a simple data dictionary, it's not going to cost you very much. You can build it in Excel, or your biologist can read it. If you want a stricter formalism, it's going to cost you a bit more. And the OBO one's kind of been inserted on here. So it's a slightly old slide, so I'm not sure if OBO really belongs there. But you have to consider your formalism and try what problem you're going to solve. When we're acquiring petabytes of data, the very, very strong formalism, some of which we heard this morning, possibly not the way we're going to go to make it scale. But there are lots of choices in here, and we're kind of dealing with quite a broad church of solutions. And then the other piece of the siren song is the FAIR tool. So this is a slide that Pete McPulton pointed me at from Susanna Sansoni's group in Oxford, when I said, can you just give me a list of all the FAIR tools? Because I'm really having trouble figuring out which one I want to use and figuring out what the difference is. And they've collected them all here, and they've done this nice representation and some analysis. And right now, if I want to evaluate my FAIR scenario, I kind of have to do it by hand. That's not really scale for us. And so I want to think about what the pragmatic things we can do across the piece that we're working in. So what are the FAIR vocabularies for us? What are the things that we should care about from FAIR vocabularies? The vocabulary should be FAIR capable, so it should have utility for FAIR data. So I think the vocabulary should just not be built because we want to build a good vocabulary. And I've chosen the word vocabulary here carefully. I don't necessarily mean an ontology, although I think in my world I would prefer it if there were ontologies. It should be usable for annotation, analysis, presentation of the data interoperability. It should be deployable in the context of a FAIR-capable data resource or tool. Maybe that's an annotation tool, maybe it's a cool database, maybe it's an analytical scenario where we would be using some workflow language. And it should have some FAIR indicators. I think we should know what the FAIR indicators are. The vocabulary itself should be FAIR. So in discussing this with my group and with Nick Duty and Carol Goebel from Manchester, we got to a dichotomy of, is the ontology FAIR because it should be FAIR as an entity, or FAIR in the context of the data? And I think the answer is both, but the goalposts shift a bit depending on your perspective. I think the vocabulary itself should be interoperable with other FAIR vocabularies. It should enable data interoperability in scenarios where you're using different vocabularies, and it should serve things like aggregator use cases. Now, we're an aggregator use case. Melissa Handel and Chris Mongol with the Monarch Initiative, where they're building aggregations across multiple species to represent phenotypes that are in common across species. And this is the difference between a mouse squeaking and a human talking, but abnormalities in both might be caused by the same gene. And so we're kind of interested in that too. So, there are the OBO principles. The OBO principles have been published more than 10 years ago. It's kind of interesting to think, are the features of their vocabulary already defined in the OBO principles? So we'd like to have a look. And so here are the open principles. And so the grey is where I think it is not fair, and the green is where I think it is a fair, useful principle. All the OBO principles, in principle, are useful. Okay? Just the context is slightly different. Okay? So I've got no issue with the fair principles. So it has to be open, CC BY or CC 0. Is that useful? So I think that all the ontologies we build should be open, but I work in the luxury of academic open biomedical ontology space. And that is not the case if you work in healthcare and you have to work with SNOMED-CT, and I now have to work with SNOMED-CT, and I have a slightly different view on this than I had when I had the luxury of working in academic space. Common format, accepted syntax, yes. I think that's useful. URI space, unique base URI, yes. Versioning, process, and releases, yes, yes, yes. We really need that for this to work. Our data resources should have this, our ontology should have this. Scope defines an aggregate scope. So I'm an aggregator. I build application ontologies that look like data. It looks like our data, so quite often it will look like your data too. Obo Foundry doesn't do that. Obo Foundry is interested in defining the space a little more and finding ways to interoperate. So I think this is not a useful principle. Textual definitions. Yes, there should be textual definitions. Again, it's a personal gift. I can see Phil's face here, which is slightly distracting. I saw an eyebrow raise there. Should the relations be used from the RO? No. I don't think we can expect Snowman to use the relations from the relationship ontology, nor do I think ICD will do that. I think it's not practical. Commitment to collaboration. No. Some of these people are just going to sell you something. I work in a space where commercial companies, clinical trials organizations, pharma companies, SMEs will just sell you something. I'm okay with people selling you things. I don't think they should have to collaborate as a core principle. I think it's nice if they do. I think it's good if they do. I think it's good for the community. Locus of authority, comms, community, and Foundry. Yes, somebody needs to own it, right? So there has to be somebody who says, we're going to maintain this thing. This is our thing. And if you want to use it, you should be able to find out how to use it. Naming conventions, no. I don't think we should have formal naming conventions. I think there's best practice. Obo Foundry principles themselves point at some quite old papers, some of them by Daniel Schober, who I used to work with, around naming conventions. I think it's not a critical piece. Maintenance, responsiveness to the scientific context. Yes, I think this is useful. So what we've done here is kind of partition the Obo principle into things which I think are useful for fair vocabulary features. So the next thing we did was to go map those back onto the fair vocabulary features themselves. And I couldn't get this all on one slide, and it looks horrible, because we did this yesterday, we finished this yesterday, and it came out of a Google spreadsheet, which I will share with people if they want, and I'm sorry it looks horrible. So fair principles, they're in the same order as the fair principles. I'm going to assume for this audience I don't need to go through these one by one, but I'll talk about the differences. So metadata assigned a globally unique and persistent identifier. Yep, we think vocabulary terms should have a globally unique and persistent identifier. Plus, we think there should be some provenance of versioning information. This is part of the fair data capability. If you're going to use it, you should have these features because you want to deploy it. So this is very much an application scenario for me. The vocabularies and the terms should have rich metadata. They should be accessible via the identifier and preferably machine readable. Not necessarily, but preferably. I don't think F3 is necessarily relevant in this case because it's about the identifier for data, and I've already covered the identifier for the ontology in the top row. The bottom row, the vocabularies and their terms are registered or indexed in a searchable resource, and I'll talk about our searchable resource in a minute, but other searchable resources are available, and competition is a good thing. So that's the first piece. And then I mapped on the Obo piece, so URIs and identifier space are there, the textual definition is there, the metadata, I think, is in the spirit of Obo 6 textual definitions. So findable. There are already services that find things in ontology space, and this is our thing that finds things, that other ones do exist. And so we have searching across ontologies, we have visualization, we've got rich metadata, and in some cases we've also got things like term history over time. The term history over time turns out to be incredibly useful if you're building the ontology. So we had this project a few years ago called Diagram, where we were looking at deltas across ontologies. And if you apply an ontology delta tool to your release cycle, what you find very quickly is the one where you really mess it up. And we found a great big bug in our release pipeline to do with URIs that basically meant we changed a lot of URIs unnecessarily and completely ruined our own ontology. We had to go and fix it. So good, we've got some indexes. Accessible vocabulary features. So, vocabularies and terms are retrievable using a standardized communication. I think that's sensible. I don't think that's particularly contentious. The protocol is open, free, and universally implementable. Again, don't think that's particularly contentious. The protocol allows for an authentication and authorization procedure when necessary. So, this one became contentious because I asserted to my group, you have to deal with commercial ontologies. They're there, we have to deal with them. And they're like, no, we don't have to deal with them, and they should be able to put them behind a firewall limit, so we don't necessarily have to have the authorization. So we disagree there in my own group. There may be disagreement in this room. But the vocabulary should be persistent over time and appropriately versioned. I think the terms should be versioned and the ontology should be versioned, and that doesn't always happen, and it gets hard to do that cleanly, particularly if you're an aggregator and you're aggregating from external ontologies, because it becomes really problematic to understand the semantics of what you're doing. I think it's important. So interoperable features. The vocabularies and their terms use a formal, accessible, and broadly applicable language for knowledge representation. So that's probably OWL, but not necessarily OWL. There are some nice features of OWL that make it really relevant in this scenario. It maps onto the OBO principle quite nicely. I didn't address I2 because I think it's slightly outside the space here. I3, qualified references to other vocabularies. Now, qualified references here can cover lots of things in this space. We work a lot with cross-references and cross-walking between ontologies. I'll talk more about that in a minute. But really, I think we should think in terms of design patterns, and there are import processes, which I know I use, some of which were developed in projects that I worked on, and which have been superseded by technology that is better for this. But we're slurping in bits of ontologies, and we want to make sure those things reference out properly. So a slight interlude to talk about vocabularies and data. So this is an example of some of the data that we have around deafness. Now, humans are deaf, mice have abnormal hearing physiology. So I've got projects right across the spectrum. I feel this one's just for you. So this is the open targets page for deafness, where we've got a number of targets associated with deafness, and you can see the links to the pathways there. The screenshot at the top is all of the deafness-related terms I could find in the GWAS catalogue, and these are all the studies that represent those, so all the associations in the genome that we know about. And in the last slide, this is a hearing loss screen from mouse, where we've got a lot of measurements around the physiology. So when we talk about deafness, we're talking about the assay, the phenotype, and the disease or syndrome. And those things need to be connected. And at the moment, in our resources, they are insufficiently connected. And I would assert that in most people's resources, those things are insufficiently connected. And if you want to build a biomarker protocol in industry, you need to kind of do that job. And so it's something that we have got implementations for, but it's not the solution I would like to have. So that's the data space, and making that piece interoperate is an interest of ours. So here's the ontology cross-reference service. It's called locally OXO. For those of you who are not British, OXO is gravy, so this is your ontology gravy. OXO provides you cross-references between ontologies. It allows you to walk up the node hierarchies, but what it doesn't do is tell you anything at all about the semantics. So there can be lots of different things in here. It might be an asserted equivalence. It might be a set of non-exact cross-references for synonyms that are kind of messy, and that's a problem, particularly when you get into highly synonymized ontologies, some of which have not been synonymized very carefully. And I think the synonym use is getting better, but the eagle eye will have noticed that I said this is a non-exact mapping from the OBO founding principles. There are lots of non-exact mappings embedded in the things that we put inside OXO. So some of the results you're going to get are not necessarily going to be exactly what we want, and I think that's problematic. So what are the reusable vocabulary features? Terms are described with a plurality of accurate and relevant attributes. Note I don't say what they are. Chris Muggle and people from my group already did some work on this. There was a YAML specification from my group. It's now implemented in OLS. That's a different piece that already exists, and I'm not going to talk about it today. Clear and accessible usage license. I don't really care what the license is, as long as you make it clear what the license is and who can use it. In OBO space, there are open licenses. I'm prepared to live in a world where the licenses are not quite so flexible. Where vocabularies use terms from other vocabularies, appropriate references are made. Now, sometimes appropriate references might get you sued, and that is going to be problematic. So I don't recommend that you get sued, but I think the appropriate references should be there. And the vocabulary should meet the domain relevant community standards. It's a direct translation of the relevant FAIR indicator. I think that's sensible. So I said that we slurp things together. We slurp things together, and this is a slightly older slide. We import from more than 10 ontologies now, but we're standardizing on some, which have actually already done some of the slurping for us. So products like Mondo, which is developed by Chris Muggle and Liz Handel, with whom we collaborate and are co-founded. So I went to look at some of the semantics in OLS to see if they were really consistent. And I've got a lot of people in my group who are very interested in design patterns and believe that design patterns are just going to save us from this semantic inconsistency. And looking at this, that looks like they're right. So this is hypoglycemia. These screenshots were all taken from OLS yesterday evening, so they're up to date. So the top one is the human phenotype ontology term. The one there that says MP is the mammalian phenotype. And R1 here is the experimental factor ontology, where we're using the HP term, but we've got a different set of semantics around it. So the axioms are different. And the axioms are done for reasons of local convenience, but they've drifted quite a lot from the source name, which is HP. And in the MP's term, it's very close to the parent term, but they're sort of retaining the identifier, which is effectively the same thing. based on at least the semantics here, they've re-identified it, and I think that's good practice. So we've got three things here which are sort of roughly the same, but actually are probably exactly the same. Now, I haven't tested that, but I think this is not the best way to do this. And I've picked my own example here because I don't think my doing this is the best way. And I know that Nico in our group would like to fix all of this and make these design patterns more consistent, at least in the open biomedical ontology space. So, pragmatism and sacrifice. So back to Circe. So here are the sailors that she turned into swine. This is the original spreadsheet that we started working on. It's got a bit larger than this, and there are a lot of comments which I took out for the purposes of this presentation. There's some disagreement even between us on what's useful here and what's not, and that's not surprising because we all come at it from different angles. So the ontologists want common design patterns to be mandatory, the data markup people just want things they can mark up data with, and somewhere we have to meet in the middle. So where do I think we should meet in the middle? So I think this is where we should meet in the middle, and here we're making some sacrifice. So Circe advised Odysseus that if you are going to sail between Scylla and Chabrus, the whirlpool and the six-headed monster, then you need to steer closer to the monster and prepare to sacrifice. So he's sacrificed 6 of his sailors, 1 for each head of the six-headed monster that was living in the cave, right? So we're going to sacrifice some stuff. So I went through the spreadsheet last night and I thought, well, which of these things do we really need? Which ones are recommended and which ones are optional? And this is my personal take. Absolutely sure that members of my group don't agree with me, and I'm pretty sure that Carol and Nick won't agree with me either. So I think the things that are essential are globally unique identifiers and persistent identifiers. I'm not so sure about provenance and versioning of information, but we can take questions on that later. I think the vocabularies and terms metadata is useful, but I don't think it's essential. And I certainly don't think machine readability is essential. We live in a world where, if you work with a large cohort, you're going to get a data dictionary. Now, they've been functioning with data dictionaries on large cohorts for many years, and quite a lot of useful data has come out of it, so that's why I'm less specific here. Should the vocabularies and terms be registered and indexed in a searchable resource? Yes. I don't want to work with native ALA files. I want to be able to search or have an API against these things. We spend a lot of time building APIs which we think work in the community. Should they be retrievable using a standard communications protocol? Yes, I think they should. Should the protocol be free, universally implemented? Yes. Should it allow for authentication? I think that's optional. The vocabularies and their terms are persistent over time and version? Yes. Formal, accessible, and broadly applicable language? Yes. Noting that I haven't specified what that is, and remembering my Bergman slide of you can get what you pay for and time is money. The vocabularies and terms use qualified references to other vocabularies, yes, but I haven't made a distinction of what I think that qualified reference is. The lowest common denominator, I think, is the X-ray. It's not what I want to work with, but it's kind of what I use at the time. Plurality of accurate and relevant attributes. It's very hard to specify that outside the context, and I said we needed context for these things. So I think this is where context comes in. If you're in a diagnostic support scenario, your relevant attributes are going to be different from the systems biology community, and I think that's kind of what I think. Usage license, yes, it should be clear. I don't think it should be necessarily open. Import standards are used, yes. Vocabularies mean domain relevant community standards, yes. I want the vocabularies to be close to the data and close to the communities that use them. Again, we had nice examples of that this morning. Anything that's not, I think it's problematic. So, consulting the Oracle, slight stretch on the Odysseus theme, but anyway. So, why do vocabularies and ontologies need to be fair? Because ontologies and vocabularies are data too. I think that's, for me, that's a kind of given. The data needs ontologies, and I think the ontologies should be internally fair too. What tools do we need? Indices, authoring tools, design patterns, annotation tools, mapping and matching tools for data and ontologies, matching ontologies together. And relevant content and context. I think those are the important things. And how do we know that? So I work in a world of mostly open biomedical ontologies, and where we knit things together, we cross-reference the commercial things and hope not to get sued. I think that when we know that we are fair is when we have use, reuse, and we can demonstrate interoperability for some of our aggregated use cases, and we can work towards convergence. So we started building an application ontology almost 10 years ago, because I couldn't work with the available ontologies in the space, and it didn't look anything like my data. And at the same time, I told you to churn through the whole of the gene expression omniverse against UMLS, and come out with 4,000 concepts that describe the whole data. And we went about it in a way, we started looking at the data, doing the markup, and then we got convergence between the work that Axel's group had done. Most things were roughly equivalent. So I think convergence tells us that if we're managing to converge on some agreement, then we're probably in decent space. And I know that organisations like SWAT4HCLS and ICD are starting to look at, for example, rare genetic disease space, which is a lot of it has come out of the academic sector. And I think rich and useful public ontologies might be an indicator for where we fare as a community. I'm getting towards the end. I've used this slide before. I've used this slide before, and I've seen Mark use it. So I was trying to think this morning on the plane, where are we on Gartner's hype cycle diagram? So we have a technology trigger, a peak of inflated expectations, a trough of disillusionment, a slope of enlightenment, and a plateau of productivity. I don't think we're at the plateau of productivity yet. I don't think we've been doing it long enough. But I think we might be at the beginning of the slope of enlightenment, possibly. Anyway, it's a personal opinion. I think we are getting to have useful things in this space. And every time we see a new context, it gets complicated again. So context is everything. So this is Penelope and Odysseus as Tischmann's painting. Public domain work, so no attribution here. So I think it's important to remember that while Odysseus was out there fighting and having adventures and tying himself to his mast to avoid the sirens and steering between Scylla and Shabrus and thinking about the sacrifice, Penelope was busy too. She was keeping it real back home. She was fighting off the suitors, and Penelope was there for Odysseus to come back to. So I think there's a journey, but I think there's also a piece of core architecture and core work that needs to be done. It's the kind of Penelope piece that says this is how we're going to do it, and we'll go on a journey. But the two things are going to need to converge at the end. So I'm kind of at the end of the presentation. I need to thank my group. So this is my group taken last year at our retreat. We're going on retreat again tomorrow. These are the people who currently sit in ontology corners. So the ontologists in my group have got a little sort of L-shaped space around the corner from the rest of the developers. And these are the people who sit there. So Ola, David, Henriette, Paula, Simon and Zoe, Nico and Warren, all were part of the thread where this got discussed, as were some colleagues from Manchester. Much of the work of my team is built on some of the people who are alumni, and I want to highlight Tony Burdett, Melanie Porto, and James Malone, who were part of this journey with us and have gone on to do slightly different things. The mouse informatics work is a collaboration. The open targets piece is a collaboration. And Carol Goebel and Nick Duty are collaborators on two projects, Fair Plus and EOS Life. Tony and Melanie have their own team now, and our GBOS catalog team are based at the NHGRI in the US and the EBI. And these are the people who fund us to do elements of this work, and it's kind of all come together in this presentation. So I hope you enjoyed it. If anybody's got any questions on Odysseus, again, people who had their hands up, please prepare to ask. And I'll take any questions on the semantic content.
Who's going to have the first question?
Please.
An interactive dialogue.
So, do you think that fairness in a vocabulary is transitive? So, does a vocabulary that's fair have to import only vocabularies that are fair or reference them?
That's a very good question.
Actually,
We'd expect nothing less from you. So I think, yes, that is desirable. Do I think that is achievable? Not necessarily. What do you think?
I don't know. I'm still thinking about it. That's why I
So I would like it to be transitive. I think it probably isn't transitive. If you work in a single domain, I think it might be possible to be transitive because you can crack things. At any point where you cross use cases or cross boundaries, so we think about the drug discovery pipeline, genetics data goes in, we know it makes a difference to the attrition rate that you have at later stages in the trials pipeline. In that kind of scenario, you're going to be dealing with Medra and Loink and genetics things. And I think in that scenario, the use case would probably mean that it's not transitive. But as somebody who enjoys building intelligence, yes, of course it should be transitive.
Helen, great talk. Ian Harrow.
Hello.
I noticed from the relatively new second generation indicators, which are hot out of the block, there's a tendency to take some of the old metrics, as they used to be called, and to have two levels of strictness. A sort of more relaxed level, and then a much tougher level, which is machine readable, whereas the softer one is human readable.
Yes.
Do you see that playing in with fair vocabulary? Is that way of thinking?
And we had that discussion, right? So there was a discussion on, do we want, so the people who commented on this are application builders, and there was a question about, do we want this to be machine readable or human readable? And the answer is both. Machine readable doesn't help the curators very much, most of the time, for example, and we have a lot of curators extracting knowledge from papers and from the data that we have. So it needs to be both. I think the machine readable piece is a more implementation piece. I think what I've described here is a more implementation specific scenario than the fair piece in general. That was kind of intentional. So both. I'm willing to consider 2 levels of strictness. I think it might have a bit to do with context and scale. If you're working at high scale, I think you probably just want machine readable. Case?
I just want to comment on that question about should other vocabularies or terminology systems be fair? Ideally, yes. So since you bring up Odyssey, I think it would be nice to mention Odyssey. Now what I mean is the Observational Healthcare Data Science and Informatics, OHDSI. And the Odyssey community, although not everyone in this room may know it, but they work on a daily basis with this problem because exactly the OMO model and the integrations that we use in the Odyssey community, they include ICD, and SNOMED, and RxNorm, and LOINC, and about 100 biomedical ontologies. Most of those are not fair. So one way, I guess, we address it in the Odyssey community is by creating these mappings. So first of all, we import versions of the ontology, which gives us at least a standard that we can then reference, even though the source may not have those identifiers. And then, of course, we make them more fair by creating all these mappings to standards. I do not think that it's possible to convince the whole healthcare industry, the $1 trillion industry, to move to standards that is fair. I would love to, but I don't think it's going to happen tomorrow.
So I think those are good points. I think there might be pockets of places where we can do this. So if I think about rare disease, we're involved in some rare disease projects. The working standard is the human phenotype ontology, and it's open. That's a scenario where we actually could possibly insist on this. So I would like to see some exemplars where we can demonstrate the value, and where you have very sparse data across many systems, but actually really one practical standard, and then you have to interoperate with the clinical record where these other standards come into play. We have to find a way of working in this space. Like I said, that doesn't get anybody sued and allows people to retain some of their IP as well. So nobody wants to give their IP to SNOMED. So I think that this is a really valuable scenario. I think what I would say is that there's a really interesting piece of work around how we think about phenotypes, right? And so part of my work now is working with Health Data Research UK, so trying to bring more research data into clinical decision making and to basically cross that bridge. If we look at the things that come out of research scenarios, so I'm working with Boston Access, who's got a beautiful paper with colleagues in the Lancet looking at patterns of disease over time. If you look at that space, how you define the disease in any one study isn't a function of the ontology. It's a function of the available data. And then translating and validating those pieces across different data sets or different healthcare scenarios and different disciplines. Renal surgeons care about different things than cardiovascular surgeons. That's a piece where I think there's an additional piece of work to be done, where we really do want that data to be fair, because we want to validate that definition of disease, that will be stroke or asthma or some kind of cardiovascular disease, and to do that very unambiguously. And I think Josh Denny and colleagues have got a nice paper in PLOS quite recently, where they've started to do this with their fee codes and to look at validation and to see if they actually perform better than clinician-mandated outcomes. And I know UK Biobank is working on something similar. So I think there's this kind of additional layer on top, which gets us back into the data space and having the data being fair, and trying to figure out where the ontology interplay is. And for me, that's going to be one of the most interesting questions in healthcare for the next 10 years.
Right. If I'm allowed one more question, so to understand the space of healthcare data, which actually inform ontologies, what we're talking about here, it would be tremendously useful to have sort of data fingerprints. And in EGA, you have tons of data that, yes, I cannot access it, but what you potentially could do is characterize these data, profile them, and provide these profiles so that we get a view on this space.
Yeah.
Is that possible? Is it something Emily BI is thinking about?
So I think it's possible. Beacons gives us some of that, right? It gives us some of the genomic profile with a tiny little slice of the phenotypic profile or the cohort profile. I think it's possible to do more in this space. So we've got projects where we are thinking about cohorts. You're on one of them, right? So there are questions about that. The same sort of questions are coming from the international 100K cohorts community, who are trying to figure out what the thin layer looks like in their scenario as well. I think the question for me is, how deep does the fingerprint have to be meaningful? And one of the challenges with EGA, which is the EBI's secure data access resource, we don't hold much of the phenotypic data. And for it to be meaningful, we need to have good links back into where that cohort data lives, and to understand which part of it we've sampled. Because whenever you work in space where people report experiments, they report the meaningful experimental variable. So like in GWAS, people will report the meaningful traits. Now there are more of those traits, but it doesn't address the underlying clinical data set. So I don't know how much you would need of that fingerprint piece to be meaningful for any given application, but I agree that it's desirable.
Yeah, thanks for your talk. So first, a comment on the hype cycle. It seems to me that I think we're still close to the peak of inflated expectations. Because I think we're in this ship that we're sailing, I think we're currently still getting more and more people on board to join us on our Odyssey, and I don't think we have quite met the six-headed monster yet, because I think once we lose 6 heads, maybe heads of department, on fair data, I think then we'll be in the trough of disillusionment, and well, hopefully after that we can rise. And it makes me wonder, also related to the fairness of the vocabularies and the vocabularies they use and so on. How do we make this sustainable? Because I think for almost every data you have, the metadata that you can add to it, is probably larger than the data you collect, if you will. Plus the maintenance, plus maybe versioning. I heard about Mons once state that, well, if you really want to do proper fair data in the big data area, you will largely spend all your money on making sure your data is well preserved. So, and what's the model for that? Because you're also, you're promoting or appreciating the open vocabularies, but open vocabularies, they need to be developed, maintained, and all of this, I mean, I've seen a lot of fair resources which were there and then suddenly disappear, so they're not so fair as they claim to be. And how do we keep this running? So what's ultimately maybe also a financial incentive to keep this fair ecosystem growing, including the provenance of data, including the further development of free and open vocabularies, and so on?
So that's an excellent question. Funders have not traditionally wanted to fund ontologies. There are very few with core funding. In my group, we always do this as an additional piece around a piece where we're doing a data management scenario or we have an application scenario. I personally like working at the application interface because I think it gives you some discipline and it allows you to pragmatically solve problems. I don't have the answer to the sustainability problem. If I did, I think I would be rich. And also how much time. I generally don't know how we do this. I think the funders have to understand that fair data doesn't come free, and then putting up a fair data tool isn't going to be a solution. But when people don't even have a data management plan. Part of the action, I think, is around data stewardship tools, and there's, Josh is here, his colleagues have got nice scenarios where we're interacting with Jupyter notebooks, and you can really get to the point where the data is being generated. The closer we get to the data generation, the better it is, but lots of our data still comes on spreadsheets, and this is not a sustainable activity. So if you have a solution, I'd be happy to hear it. I don't have one.
If I had one, I would have asked the question.
Yeah, well,
I would be rich as well.
Happy to discuss it.
Yeah, so I'm in the trouble of disillusionment, but probably
But you have
says
been
more about me
contributing.
than... Yeah, also we've been talking about sustainability for 15 or 20 years, and we still are here. So maybe it's more of a solved issue than we think.
So the Nucleotide Archive has been going for more than 30 years, and PDB is also more than 30 years. So for those things, we've got partial solutions, but they're not optimal solutions.
So my question, my question, which is, you talked about interoperability of vocabularies.
Yeah.
So another one of those different ones. Does that interoperability imply consistency? So you show your lack of accurate semantic mappings. You can clearly pull those ontologies into one space,
Yeah.
but they have inconsistent semantics, and I think that's probably for their own individual application.
Yes. So I think for some applications it does imply consistency. And Monarch, for example, want to be internally consistent, and they have very good reason for it. It matters a bit less for us, but there are fringe benefits, because it does mean that we actually can build tools to apply things in a consistent way. So I think the answer is sometimes.
Thank you. All right, one more. Yes, this should probably be the last question. I wanted to ask your opinion about, so making the data fair, of course, we all agree that it's good for reproducible, but it's not painful in the sense that you also need to, invest time. That means hiring people, spending money. So what do you think will be a killer application? Because what we see is that we make our data fair for our own research, which means that already we have people that will work on that. But what do you think are some killer applications that can eventually, speed up and also bring money then to make data more fair?
So I've got two. So one has been paradigm changing for us. So working with Open Targets, a consortium of pharma companies who are willing to put some money in to replace that kind of pre-competitive part of their own pipelines, and then suck our tools in. So I know that some of our tools are running at some of those pharma partners, and they are doing different things with them than we do, and that's great. So I think there's that kind of paradigm changing piece, and for us at EBI, that was the first time we'd ever looked across the breadth of the data, but also figured out what to do with the experimentalists at the point they're designing the experiments, and not waiting until after it came, washed over the doorstep and trying to figure out what to do. So that's one scenario. So that public-private partnership, which is a true collaboration and not a contract, has been really inspirational. And then the other piece, I went recently to a clinical trials workshop that we held, and I came and talked about open health data from Health Data Research UK. And there was really a change in the room among the people in the room who were all from different trials parts of different companies saying, we believe that our data should be fair, and all of it's fine. We always say that, but lots of it was applied from CROs, and that's all fine. But we still want it to be fair because we think it has value for the company to work in this way. And partner after partner got up and said, we've built this thing and we think it's fair, and this is how we do it. And I think that kind of adoption and understanding what motivates those people, and they were discussing whether or not we might want to put some data in the public domain as examples of value. And so if you can get really large organizations on board, you have a lot of R&D money, that can be quite convincing. Now, there are not that many of those, but I think there are two application areas I can think of where pharma is not necessarily making money. And one is antimicrobials, where we've got a massive worldwide problem, and not only do the pharma companies own that, but Gates Foundation has a stake in it, Market Trust, and so on. So really global problems. And the other one is neurodegenerative disease, which many of us in this room are going to get neurodegenerative disease. I'm female, I might not long enough to get it. I think that there are scenarios where if we think about public-private scenarios, those are going to be good ones to work on, just because they're biologically difficult problems, and the traditional routes of pharma haven't worked well. Did that answer your question?
Yes, I have another one.
Okay, so unfortunately I am going to have to leave reasonably soon, but if anybody's interested, I will be happy to circulate the link to the horrible spreadsheet, and we would like to build a white paper and publish it. And if anybody wants to come and play with us while we build this white paper and think more about this, we will be happy to talk to you. Thanks very much for your attention. I really enjoyed this question.